Hello everyone, welcome back to Coding Encrypt. My name is Sylvester and today we'll be delving into arrays. More specifically, the sorting of arrays. So let's refresh ourselves a little bit and remind ourselves what exactly is an array. An array is a collection of elements of the same data type. So it can be either completely of integers, completely of floating point numbers, completely of characters, completely of strings, but it cannot be a mix of both. And one limitation to arrays is that its size is fixed once it is declared. So if the size of an array is 5, it will remain 5 and you cannot change it. And you cannot add a sixth element while the code is running. You have to change that beforehand. So let's suppose there is an array. So I'm going to show you what is the advantages of an array. So we have an array over here. So let's just assume that the starting element of the array is actually 1 rather than 0. So we have Alice, Bob and Charlie. And we have a separate array which is associated with the names, which are the English marks. And let us suppose that a teacher wants to figure out what exactly the marks of Bob is. Now we know that the roll number of Bob is 2, as we can see over here. So all the teacher has to do is check the second index number of the English marks array, and he or she will immediately find out that Bob's English marks are 96 out of 100. So this is an advantage of an array. It optimizes code by combining similar data into one unit. And also if we know the the index number of the element of the array, then we can immediately find out what we need. And this is how we declare an array. We have the data type followed by box brackets, the name of the array, which could be anything, and then equal to new, the same data type. So if we started with string, you have to have string over here, and then in box brackets the subscript, which is the number of elements within the array. So let me show you in our Java IDE BlueJ the different ways where you can declare an array. So we can have the box brackets right after the data type. We could have right before the name or after the name. All of them are completely fine. If I compile this, no errors will appear. And we can have two different ways of initializing an array. One way is to immediately give the elements, but one thing you must keep in mind is that if we have 4 over here, as we can see, 1, 2, 3, 4, we cannot increase the number of elements. It has to be 4. We can replace them but not increase the number of elements. And here the subscript of the array is 5, and in the string array it's 25. So let's get back to the presentation and move on to the various sorting algorithms there are in Java. So we have the bubble sort and the selection sort. These are the two most basic sorting algorithms, and they're also the simplest to understand. So I'm about to show you how exactly bubble sort works. So a bubble sort is a sorting algorithm that checks two adjacent pairs of data and then compares their value. So you could compare the integer value or floating point value. You could also compare the ASCII value of a character. As long as you can take the data and turn it into a value, sorting algorithms will work for you. So let's suppose an array with 7, 3, 9, 2 and 1 as its elements. In bubble sort, we first check two adjacent elements. So we normally start from the first two, but if you'd like to, you could start from the last two elements. We then check, so here we want to arrange it in ascending order. So we check whether 7, which is the first element over here, is greater than 3. If yes, then we swap them. And if not, we don't swap them. So as we can see over here, 7 and 9, completely fine. 7 is less than 9, so we don't need to swap them. We move on. 9 is greater than 2, so we need to swap them. And finally 9 is greater than 1, so we swap them. So one thing you might notice is that each time the bubble sort sweeps through an array, so after the first step we get the largest value if we're arranging in ascending order at the end. So the next time we sweep through it, we don't need to check the last one, as we already know that it's most definitely at the right place. So as we can see now, in the second step, 7 ends up at the end. And if we repeat this 3 more times, we get the sorted array 1, 2, 3, 7 and 9. So in Java, we have multiple ways to actually do the bubble sort, but this is one of the simplest ways over here. So as you can see, we have the same array over here, 7, 3, 9, 2 and 1. And we have a nested loop over here, with the outer loop being I and the inner loop being j. So let's break down the outer loop first. We have I is equal to 0. Why? Because 0 is the first index number in any array. And we don't start at 1, we always have to start at 0. Then I is less than the array length minus 1. Now you might wonder why minus 1. Well, because since we check the array element over here, so if I is equal to 0, we check 7 and we also check 3 and compare them. But if you were to check 1, well then there's no element after that. That's the end of the array and we would end up in an out of bounds exception error. So to avoid this, we have a minus 1. And of course we have an increment variable. Now let's dissect this inner loop. So we have j is equal to 0 since each time we sweep through the array, we want to make sure that we go through every single one of them just to make sure that everything is sorted. So we have j equals 0, so 7 and 3 will be checked first. If j is equal 1, 3, 9, then 9, 2 and 2, 1. But then you also notice that j has to be less than the array length minus 1 of course, but minus I. Why is that? Well, because each time we sweep through the array, the greatest value ends up at the correct place. So we can just ignore it each time. So each time I goes up by 1, we can ignore the last few already sorted values and then we increment. Then we have a block, if block over here, which compares the two values, and if they happen to be out of order, well then we swap them. So to swap them, we need a temporary variable over here, which here is temp, and then we store the first value. So if j is equal to 0, we store 7 in the temporary variable. Then the 7, the index value for 7 is now equal to 3. So the first index value is now equal to 3, and when we swap it, and the next value is equal to temp, because the original value which was stored in the 0th index value is already been replaced. So we need to use a temporary variable in order to store this. And also just to optimize the bubble sort, we have a Boolean variable as well. Why do we have a Boolean variable first of all? Well, the main reason is there might be the chance that the array could be sorted well before we would think it should be sorted. So if for example we had an array 2, 1, 3, 4 and 5, well then after the first sweep it's already sorted, so we don't need to check it another 4 times. So the one thing that this Boolean variable does is check whether the complete array is already sorted well before we would think it would be. So after the first step, we find out that the Boolean variable is false, which means that we do not exit the bubble sort loop. But the next time we go on, we do exit it, since we never enter this if block, because if when it's sorted, array of j is never greater than array of j plus 1. So that's the main reason we have over here a Boolean variable. So let me just run this right over here, and as you can see, I've already printed out the various steps required. So as you can see, after step 1, 1, 2, 3, 4, 5, step 2, 1, 2, 3, 4, 5. So it only required 2 steps, so it exited the loop once everything was done. So let's check if it works for our previous one. So you might remember it was 3, 7, 2, 1 and 9. Let's compile this, rerun this, and as you can see, everything goes just as planned. We have 3, 2, 1, 7 and 9. And then we sort it after the second step, the third step, and finally the fourth step. It's completed. So we exit the loop, the array is sorted, and we can go by our day. So next we'll go on to the selection sort, which is the next sort over here. In selection sort, rather than always comparing two adjacent values, it's a sorting algorithm which first finds the smallest value within the array and places it in the first spot. Then in the second time the array is checked, we ignore the first spot since we know it's in the correct spot, and we find the second smallest value in the array. And then we go to the third smallest, the fourth smallest, fifth smallest, until we're done with sorting the array. So here's the same example array as before. So we have a variable which actually checks for the smallest value within the array. So 3 is less than 7, so we set that as the smallest. 9 is not less than, 2 is less than, so we set that to the smallest, and then we go to 1. 1 is the smallest, and we find out that since 1 is the smallest, all we need to do is swap the first element with 1, and there we go, the smallest value is in the correct spot. And we repeat this again and again until we get our sorted array. So let me jump back to BlueJ and show you how exactly this is. So let me just open the class. This is a select sort. Alright, so as you can see over here, we have the same array, but this time in our outer loop we have I equals 0 and I is less than the array length minus 1. Once again minus 1, as if since the first 4 values, if they are sorted, we know that the entire thing will be sorted. So we need not check the last value of the array. And we have as well the minimum variable over here. Now here we don't store the value which is contained within the array, but rather the element number. Why is that? Because it's a lot more easier to deal with it rather than having to store the value and constantly change it. It's a lot easier to just store the index number. Now we have j equal to j plus 1. Now why is this? The main reason for this is because we do not want to compare 7 over here with itself, because we already know that that is equal to the smallest value which we have set in the first thing, in the first sweep of the array. So we need not check that value. And the if statement over here checks for the for any value that is smaller than whatever is already stored within the min variable. And then after all that is done, we swap the values, once again having the temporary variable. And I will also be printing each step one by one, so that you can get an idea of what is happening in the background when the computer runs the sorting algorithm. Alright, so let me just run the selection sort. Alright, so as you can see, it sorts the entire array 1 2 3 7 9, which is completely sorted, and that is it. So that is our selection sort. So let's go back to our presentation. So those are the two simplest sorting algorithms for arrays, and that's about it. But before you guys leave, I would like to give you a challenge. Take the bubble sort, and instead of checking the first two values, check the last two values. So if you remember, in our bubble sort over here, we check the first two values and then move on to from left to right. So what I would like you to do is, instead of checking the first two values, go from the last two values and go from right to left. It's a fun coding challenge, so that you can actually get a better idea of how these sorting algorithms work and how to declare your loops correctly, so that it sorts the array quickly and efficiently. And that's the end of our lesson over here. Thank you all for watching. If you liked the lesson, feel free to press the like button, and if you'd like to stay up to date with future videos, press that subscribe button. I'd like to thank you all for watching. Goodbye.